Hi all. This week we're going to talk about zoonotic infections. Zoonoses are defined as any disease condition that can be transferred from animals to humans. The reason why this topic is critical to talk about specifically in an epidemiology course is the fact that there are so many zoonotic diseases. They say that over half of all human infectious diseases originate from animals, and that 70% of emerging diseases are originating from animals or are zoonotic. So an emerging disease is a new disease condition. So an example of this would be SARS. SARS, for example, was a few years ago. It was a upper respiratory condition that is associated with a particular cat species in Asia. So SARS is an example. West Nile virus is associated with animals as well. It's an emerging disease. The other term associated here is what's called a re-emerging disease. So it's a disease that has been previously controlled, which is now coming back. And a lot of those are also zoonotic diseases. The other issue associated with zoonotic diseases is that recent surveys have shown that if you ask clinicians, nurse practitioners, doctors, physician's assistants, people that work with humans, they do not feel like they really learn enough about zoonotic diseases in the curriculum. And given that there's so many of them and they're so prevalent, that's one other reason why I want to focus on this a little bit, because a lot of the students, a lot of you that are taking this class are interested in potentially working in human medicine, and it's important that you get at least some introduction to zoonotic disease. There was an interesting article in the Journal of Agromedicine, if you want to take a look at it, as far as how physicians felt kind of underprepared to try to deal with answering their patients' questions regarding this topic. So to try to deal with this nationwide, there was a task force formed in 2008 between the American Medical Association and the American Veterinary Medical Association. And the primary purpose of this, the One Health movement, is to try to increase communication between different medical professionals, between human and veterinarians and public health professionals, so that we can get a better understanding and try to get a feel for what's going on with these diseases faster. So to give you an example, when the West Nile virus broke out in the US, simultaneous to human cases, there were people that started noticing that there was a lot of deaths in crows. And a veterinarian at a zoo in New York State was one of the first people to kind of make this connection that we're having issues in humans and massive deaths in crows. Apparently they were so bad that the crows would just fall out of the sky and you'd have tons of dead crows all over the ground when the virus first struck in the Northeast. And she submitted samples to the CDC saying that she thought they might be connected, and they were essentially ignored for a very long time because no one there made the connection that agreed with her thought they could be connected, that the same virus could be affecting the humans that's affecting the crows. If they had paid attention to that, we might have figured out much faster what was actually causing this disease in people. And that's part of the reason what stimulated this One Health idea, is to try to get better communication ongoing between different aspects of medicine, because they are all interrelated. To give you some sense, this is a graph, a map rather, of various emerging and re-emerging infections that are recent. And as you can see, that 70% of them are either zoonotic or they're vector-borne. Vector-borne means to be carried by an animal or arthropod vector of some kind. And so you'll see that, some of these are some pretty scary conditions. So Ebola, for example, West Nile, as I mentioned, SARS, avian influenza, and then there's a lot of them you've probably never heard of. I haven't heard of some of these either, to be honest. And these are all new or previously known conditions that had gone away that have re-emerged recently. So what we're going to do in this PowerPoint is go through a few specific examples of zoonotic conditions. And I didn't pick some of the more unique ones as you see on this slide. What I did instead was to pick ones that are more common in the United States, ones that you might actually come across or know someone who's had, or as you continue in your careers, ones that you need to be familiar with. So the first one that we'll start with is cryptosporidiosis. So cryptosporidiosis causes diarrhea, and it's usually what's referred to as self-limiting. And basically what that means is it's a very mild diarrhea. Typically it can be treated with over-the-counter medications or no medications at all. And it doesn't result in a lot of hospitalizations or other issues in that way. So as a result of that, when people have crypto, the number of people that have been diagnosed is much, much less than those that actually have it, because the majority of people just stay at home for work a day or so and deal with the diarrhea, and so they never actually get diagnosed. It's caused by a coccidia, which is a type of protozoal parasite. And it has a variety of different kinds of hosts. So there's a species that are common in humans, and there's also ones that are common in different types of ungulates, such as cattle or deer or elk. And those ones in cattle and deer and elk have been known to cause human illness as well. So the parasite itself is transmitted primarily fecal-oral, meaning you somehow or other get fecal material that's contaminated with this parasite into the oral cavity, most commonly through waterborne. So if in the case of a human passing it to a human, this is typically because someone has the parasite and it's not being properly cleaned out of the water supply. In the case of an animal passing it to a human, it's because an animal has defecated into the water, and let's say you're out hiking or camping and you haven't appropriately cleaned the water before you drink it. That would be an example of how you would get it from an animal. The other thing about this particular parasite, which is not common necessarily in a lot of parasitic diseases, is there is no intermediate host required. So most parasitic diseases require a host that is necessary for reproduction only of the parasite. So if you have an infected person or animal, they shed the parasite in their feces. It is then taken up by another host, the intermediate host, and in that host becomes infectious. So it requires a second host in order for a person to become infected again. So you can't be infected directly from the person or the animal. That's not the case with crypto. With crypto, you could have an infected person or animal. They shed it in their feces, and it can directly infect someone else, not requiring the intermediate host. So a way to control a lot of parasites is to get rid of the intermediate host. So if you don't have the intermediate host, then you can never get the infectious form for some of these parasites. That won't work with crypto. I wanted to talk a little bit about the life cycle of this particular parasite. So this graph or graphic over here on the left is from the CDC, and we're not going to go into all these details. It's a little more detailed than I really want you to know, but let's talk about some of the generalities about the life cycle of crypto. So first thing you need to know is it infects the epithelium of the intestines. And this is regardless of whether it's in a person or an animal. So that's how the parasite causes its damage, and the diarrhea is by causing damage to the epithelium of the small intestine specifically, small and large intestine. And so what we want to talk a little bit about is the forms of the parasite and how it gets in there. So the form that is shed by the infected person or animal is what's called an oocyst, excuse me. And oocysts tend to be very protected structures. And what I mean by that is that they're protected from the environment and they can last outside the host for quite a while. And these oocysts are typically shed into water, as I was mentioning earlier. And so the first step of infection is you consume an oocyst from the water source. Within the cyst is another form of the parasite that's called a sporozoite. And so this comes out of the cyst once it's been consumed. And this particular form is the form that actually can attach to intestinal walls. So the sporozoite is the form that can attach to the intestinal walls. Once it's in the intestinal walls, there's a third form of the parasite I want you to be familiar with called the merozoite, and that is the reproductive form. So the merozoite is what undergoes reproduction to create more oocysts that are then released into the infected person's feces, and they then defecate, and these cysts end up in the water supply. So there's three specific forms that you need to pay attention to. There's the oocyst, the sporozoite, and the merozoite. So for each of those, you need to know what their role is in the process. So here's an example of how this can happen. And this is actually a really common outbreak, Cryptosporidia. So in Milwaukee, there was quite a large outbreak in the early 90s. They had, that they knew of, 400,000 people who became ill with crypto. But as I was mentioning earlier, the actual number is probably much, much higher than that. And of those 400,000, 100 people died. So most people have very mild illness, but if someone is immunocompromised, so for example, an HIV, AIDS patient, or the elderly, or the very young, it is possible they can get severe enough of a disease that they can die basically from severe dehydration. This particular outbreak was not zoonotic. That was from a human, though there have been outbreaks in Washington state, for example. that were zoonotic from large cattle facilities. And what they found was because that there was something that happened with the water treatment process in Milwaukee, and so it wasn't killing the cysts. There was someone who was infected. They were defecating it, flushing it down the toilet. Then it was going to the wastewater treatment plant and not being properly treated, being released, and making it into the actual water supply. The thing that's really important about crypto is chlorine won't kill it, which is pretty unusual. Most parasites and other contaminants are very easily killed by chlorine, and that is not the case here. And so the only way to really get rid of it when it's in the water supply is by boiling. So when you hear about municipalities that say, don't drink the water without boiling it, it's most likely this particular parasite that they're trying to get under control. Now, the wastewater treatment plants have ways of handling this other than chlorine. They have other methods for killing this, and also the water plants. But chlorine, which is a very common method of disinfection, was not going to work. It's also a little challenging to diagnose. And the reason why is in order to diagnose it, you have to look for the oocysts in feces, and they are not shed or released continuously. And so typically the way that you have to do it is you have to submit a series of 3 fecal samples, can you imagine how much fun that would be, to the lab, and they take a look and try to find them. And usually if you submit at least 3 samples, it can be found in the samples if it's there. I had a friend that had to do this, and so she submitted her samples, and then the lab lost the samples and she had to resubmit the samples. She said it was one of the worst things she had to do was to submit these samples to the lab. The other way of trying to look for it is by doing serology, which is looking for antibodies, or depending on the type of test, antigens in a blood sample. And specifically using what's called the ELISA. This stands for Enzyme-Linked Immunosorbent Assay. We're going to spend next week and the week after, the very end of the semester actually, the last topic, talking about different types of serology tests and how they're used. And so later I'll explain how an ELISA works. But for now, just know that it is a serology test. It looks for antibodies or antigen in a sample. And so it's another way of diagnosing crypto as if you have this present in your blood. So the way the discussion posts are going to work for this particular topic is there's 4 options. And everyone can't choose the same option. So there's no more than 4 students that can choose a particular option. And so as you go through this PowerPoint with me, you'll see that there's different ones you can choose from. So the first one is looking at cryptosporidium. So it is looking at what methods do water treatment plants use to prevent it? How would you survey for it? So if you thought there might be crypto in a population, what would you do to try to quickly identify or find out people that might have it? And then what preventative measures are recommended to try to prevent it, both as an individual, so you personally don't get sick, and then as the community. So the way this will work is some of you will pick this option. As soon as this option has been picked by 4 people, then no one else can pick this option again. So it's first come, first serve. And you'll be responsible for the information that everybody posts on this last exam in regards to this particular topic. So you want to make sure you go through and carefully read all the discussion posts as well. And what we're going to be focusing on for the zoonotic infections is looking at ways to try to prevent them. That's probably the most important thing, is how do we prevent the zoonotic disease from crossing over and infecting humans.